This is Project 7 of Hacking in Swift. We're going to make a new app to show petitions to the White House using a number of new things, not least tab bar controllers, data types, and a new file format called JSON. For more information, please see the website hackingwithswift.com, where you can buy this tutorial and indeed the entire series as downloadable ebooks for a very low price. Or you can buy high-resolution versions of the videos too, or buy both, all of which help support my work and make more videos like this one. So please, if this video is helpful to you, buy a book, buy them all, buy some videos, or please just support me somehow. Alternatively, get in touch on Twitter. I am at 2straws. If I can help you, I'll do my best. Keep in mind my time is limited, but I will do my best to help you. Give me a head up on at 2straws. So our project is to build an app to parse this information. This is we the people. This is not, by the way, this is not a political statement. I don't really care which way you vote, if you're American or not. I am not, by the way. I have no say in any of this stuff. I really don't care what's in here. This is not a political statement. I'm using we the people because they publish data openly in what's called an API. And an API is a way we can ask for data and receive it back in a format we can then parse and use in our application. So we the people is very good because it's done by the government and therefore has a lot of open data. And we can actually request data from here, get it back and show it in our app. And that's what our app will do. It will create an app that shows the most popular petitions for we the people. If I remember correctly, it's something like if they get enough signatures, then I believe the president's obliged to respond, or Congress is obliged to talk about it, or something like that. So it's very interesting. A lot of folks use it for jokes. There's one on there that says, we want the US to build Death Star, like out of Star Wars. But some folks obviously use it for very serious stuff. Again, we just don't care what's in there. We just care the data's available. So that's what we're going to build, and we're going to learn about the tab bar controller, which is another really, really important component inside iOS. So I'll just hide that for now and fire up Xcode. Please follow along. Go to create a new Xcode project, then choose iOS, application, master detail application, and click next. We've used this template before. You're probably bored of it by now. Name your thing Project 7, Swift, iPhone, no core data like usual. Then press next. Save to your desktop's fine. So this is exactly the same thing we've built so many times before. You can go to the main storyboard. It's like your old friend now. We've got a navigation controller, inside that table view controller, inside that, or after that being pushed across, this detail controller. Old news by now. What we're going to do though is show petitions in two tabs of a tab bar controller. So if I play this back now, you'll see how it looks. Let's go to iPhone 5S and press play to build and run the code. You'll have seen it 1,000 times before. It's just the press plus to add date stuff. Look, there we go, nice and big. Plus dates, fantastic. We're going to add a tab bar controller, and these things sit at the top of your application. So I'll select my master view controller, just clicking in there, and go to editor, embed inside tab bar controller. And it'll push along and show here's tab bar controller, then here's navigation controller, then here's table view, then here's detail view. And I'll play that back so you can see how it looks. So now across the bottom we've got this tab bar with item with no picture in. And this you'll see in so many different iOS applications, such as the App Store, such as the phone app, such as the music app. And by default you can fit 5 icons in there. That's 5 different view controllers being used inside the tab bar controller. If you have more than that, like say in the music application, there's like genres and albums and all these kind of ways of sorting music, you get a more button which shows the rest of the tabs, all managed for you by the tab bar controller. All you do is add things to it and it does it automatically. And when you add a tab bar controller and add something to it, you'll see it gets a tab bar item. This thing across the bottom here, it says item with a square in the middle. If I choose that, I can customize the text. I can say, listen, this is the awesome tab, whatever. And now there's the word awesome in there, and you'll see it's here too, awesome. Alternatively, I can either give it title or image myself, or I can say use a system item. So I want to use the featured. You get the word featured and a star, and this will become automatically localized depending on who's running the app. So if the app's being run in France by a French person, it'll have the French word for featured, and even the star could potentially change as well to be location specific to mean a good thing. So if you run that now, you'll see our tab now has a star on the word featured. Fantastic. It's selected. That's why it's filled in. And an interesting thing about Apple is if you try and change that word featured to be something else, let's go back to being awesome again, because awesome is awesome. Great. The star's gone away. Back to the no picture thing. That's because Apple spends a long time training its users to know that star equals favorites, at least for English language users. And you can't change that, because if you were to put, this bit sucks underneath the star, it would really confuse your users and start to untrain Apple's own users. So they are quite fussy about your usage of that. Now, what we want to do really in our tab bar controller, the reason it actually exists, and it is really just to try and force some more iOS on you, ultimately, but the reason we're going to use it in this project is so we can show the most popular petitions in the first tab, and then in the second tab we'll show newest petitions or something else. So there's two different views we can have, recent or popular. And realistically, it's the same code. The same code: fetch the data, parse the data, show the data, select the data. All we're doing is saying, don't get this feed, get that feed instead. So it's the same code. We're sharing this navigation controller, sharing this table view, sharing the detail view. All we're doing is changing the data feed behind it. So what we want to do really is have 2 tabs in here, or 3 or 4 or 5 tabs in there. But actually, this is quite hard to do. At least to my knowledge, I haven't seen an easy way of doing this. If I were to, say, add this navigation controller again, what I'd do is I'd control drag from tab bar controller up to master and say view controllers, and it adds it to the array. So you can see, well, it's there twice now. That wasn't too hard at all, Paul. Well, fantastic. Let's add it a third time. Look, view controllers. So each time you're doing that, it's adding this view controller again and again and again to the array of view controllers that belong to this tab bar controller. So we've now got awesome, 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 which is clearly very awesome. And you'll see it appears 3 times. So it kind of looks like it works. What's the problem? Why is it so hard? Well, here we go. Let's say, actually, clearly I want to go back to featured or go back to history. And now press play. What you'll see is history, history, history. All 3 have changed because we've changed that one and it's a copy of it 3 times. So we can't have 3 different tab bar items. These things at the bottom, these tab bar items, are the same for every tab, which is rubbish. We don't want that. So I'm going to delete the relationship, so it only appears in there once. You'll see now only 1 tab in there. We're going to create the duplicates in code so we can change it more easily, which makes our life much, much easier. Before we leave our storyboard, we're going to do a few more little things, specifically 2 more things. Firstly, we want to, put this back to being something useful, so let's pull that popular again, which is fine. But what we want to do really is give this navigation controller what's called a storyboard ID. A storyboard ID lives inside this inspector here. It's called the identity inspector. So far you've been here, the attribute inspector, or here, the size inspector. Now it's time for the identity inspector. Click on that and you'll see a few options here. These things, realistically, you very rarely touch. They describe the navigation controller in non-visual ways, things your users can't really see. And what we're going to do is we're going to give our controller here a name of nav controller. And it means later we can say, create me a new navigation controller, and it'll find it using this name. So the name there is very important. We're not going to use it now. It'll sit there rotting in our code for a few minutes, if not half an hour or so. But we'll use it shortly to work correctly. The second thing we're going to do is over here in our table view controller, I'd like you to select this cell here, that thing, and go to the attributes inspector and change style basic to style subtitle. And you'll see it now goes title subtitle. So we have another row of text in there we can do something interesting with. That's enough for the storyboard for now. Go to master-viewcontroller.swift. We're going to make a few changes, the kind of changes you've seen so many times so far, which means deleting all of the insert new object methods. We don't need any of that stuff. Deleting most of view-did-load, because we don't need any of that stuff too, but leave, please, super view-did-load. Even though it does nothing, just leave it in there, please. It's important to be nice. We want to delete the commit editing style method again down here and candidate row at index path. This is just what you've done before already. It's nothing new. In fact, it should be almost memory view at this point. And then delete the as NSDate, delete the dot description, and delete the as NSDate here. On Xcode 6.2, my version, the tabbing there is always wrong. It irks me slightly. Let's fix that too. And that's it. Step 1 is now complete. Now, there are errors in our code and warnings in our code. Our code is not ready to run. It's temporarily broken, but that's okay. We're going to fix it up in just a second. Let's talk a little bit about JSON. So JSON is the data format that the petitions site publishes stuff in. And actually, it's very hard to find good, reliable, interesting, and available free data out there. So actually the We the People choice is great because it is available and you can get it and I can get it and it costs no money to use. It's really, really easy to use. The JSON's just there to download. And JSON stands for JavaScript Object Notation. It's a JavaScript method of sending data around in a really condensed way. And it is condensed. It's quite hideous to read. I have some over here in my Chrome window here. This is what the actual WhiteHouse.gov JSON looks like. It is designed for machines to parse. It's not really great for humans, but you can look through it and start to see things in here, you know, the shape of things. So here we have a ID number for petition, type petition, title, stop the FAA from discriminating against small UA, stop hating drones, is that petition I think, which is fine. Then some body text about it. There's another one here, revokes citizenship of Mrs. Muse, who likes North Korea. Okay, fair enough. But you know, I'm not judging people here. I'm not really interested in the data, just the fact that it exists. So you'll see it's sending us back loads of petition data. You can see things like how many signatures has it got, how many does it need, what's the URL to more information, what's its deadline, and so forth. So there's a lot of information here in the JSON, and we want to put that into our program. But first up, we looked at in the previous project about auto layout, we looked at dictionaries just briefly, and I didn't really explain them too much because I just wanted to get it out of the way and focus on auto layout. We're going to talk a bit more about dictionaries first because we're going to use dictionaries in this project, and we're going to use them in quite a cunning / lazy way, depending on how you look at it. So to recap, if we wanted to have an array of strings, we would say var my strings equals string, like that. So that declares it as an array of string, and that creates it. The parentheses at the end creates a thing. So that means create me a new array of strings called strings. And if you remember from project 6, we make dictionaries by saying var labels equals a key name, string, then a colon, then a value name. So I'm going to store UI labels, just like we were doing in the last project. So that creates a new dictionary where the key is a string and the value is UI label. We can then do things like labels meh equals some UI label. So that's the difference between arrays and dictionaries. They're different. You use them both all the time. In this project, and this is why it's lazy a little bit, we are going to make an array that contains dictionaries. And this really is a short circuit because I don't want to introduce you to the complexity of what the real smart solution is here. This is a good enough solution for now to keep things nice and easy. So we have to combine this syntax and this syntax together to get our thing. So first up, our data is going to be key string, value string, like that. So it's going to be things like I had it before. What was it? Labels, first name equals Bilbo, whatever you like, and then another one could be labels last name equals back into whatever you want, right? So it can hold a key as a string and a value as a string. That's what that means here. We want that to be the kind of data we're storing. Key value, string, string. But it needs to be an array of that. And what this looks like is, if I copy and paste, it looks like that. Bracket, bracket, string, colon, string, bracket, bracket, parenthesis. So dictionary where key is string and value is string. Around that, bracket, bracket meaning array of, and then create it. So that's what we're going to do here to store our parsed JSON information. So we're going to take that here, remove it. I've put it onto the clipboard with Command X, and replace it with our var object. So var object equals bracket, bracket, string, colon, string, bracket, bracket, parentheses. So our object was previously an array of any object, and now it is an array of dictionaries where each dictionary holds a string and a string. So with that in place, we are able now to hold some JSON, because that's enough for us. What we're trying to do is parse all these petitions into a meaningful form. So it's an array of petitions. Each item will be a single petition. And for each petition, we're going to store key, title, value, text. Key, title, value, text. That's why it's string, string, text, text, title, title, text, body, body, text. And it's an array of petitions. So it's an array of dictionaries. So it's time now to try and parse some JSON. And parsing JSON without explaining for many hours is extremely hard in Swift because of the optional thing you have where you try and pull a key out. Is it there? Is it not? Unwrap the optional, have a look. Oh, it isn't. Move on. It's very, very difficult. We're going to use a library, a brilliant library called SwiftyJSON. And it's included in the project files for this project. So if you look in your project files folder, you will see swiftyjson.swift. Drag that into your project, let go, make sure you choose copy items, create groups, and leave targets alone. Press finish, it'll pop in. And this is a much faster way of parsing JSON. It's a lightning fast way of parsing JSON. Because using this, you can basically describe the path you want to get to and what you're looking for, and it'll return you a value or nothing at all. Much, much easier. It's much safer as well. So to recap, let's look at our JSON just briefly again. We can see that a petition, where are we seeing here? So it has created date, is it signable? Here's a new one here. That starts a new one there. And ends somewhere down here, I guess. Ending here, that's where it ends. That is one full petition there. So it has an ID with a long number, type petition, title, long text, body, lots of body text. Then issues is disabilities and family and human rights. Then other information here. But that is one petition. So we can see what we care about is things like ID, title, body, and signatures for popularity reasons, right? We want to use that information to navigate our way through. And first up, let's scroll to the very, very top and see what other information we have at the very top. Because you can see here, there is some metadata, response info, a status, developer message, and then a load of results, a load of petitions. So we're going to try and parse that out. Now, what I normally find useful when looking at this kind of thing is to use something like JSON formatter, because you can literally paste JSON in there. So I can go in here and select all that text and paste it in here and press process, and it will format it nicely. There we go. So I can now see the JSON much, much more clearly thanks to JSON formatter. So you can now see exactly that's one result there with all its issues all laid out nicely, and then another result, another result, another result, and so forth. And at the top you can see the metadata. So it's got metadata, response info, status, other stuff, request info, yada, yada, yada. Lots of stuff we can read through. Now we get, probably 3,000 or 4,000 lines of JSON to parse through. And it's all repeating. It's petition, 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 again, 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 again. What we're going to do now is just look at a few in particular things. First up, we can see there is a metadata field at the beginning, which contains a response info value, which contains a status. Status 200, by the way, is the web way of saying everything is okay, it all worked fine. Then beneath that, if you look below, you will see a results key, which contains all petitions as an array going down the way. Third up, each petition has a title and a body and some issues it relates to, plus some signature information beneath it. We'll use all that. And you'll also see that JSON has strings and integers too. So you can see strings have quotes around them, integers do not. Otherwise, it's just a load of text nicely formatted. But these guys are actually very helpful for formatting your JSON quickly and easily. So it's time to write some code. Enough looking at this stuff, let's write some code. In viewDidLoad of your master view controller, we're going to modify this so it downloads that text from the Whitehouse and parses it using SwiftyJSON. So we have to use NS URLs for this. You remember NS URL, we used it already at least in project 4 and actually in project 3. And they just convert a string into a more clean, useful format. So we're going to start by declaring our string so we know exactly what we're doing. And our URL was, what is it? It's that. So var URL string equals that. That's our URL string. It's variable. It can be changed later, and that's important because we'll be adding 2 tabs later with 2 different data feeds. That's why I've got it separated out quite nicely. So var URL string equals that long URL to get the basic information on petitions, recent stuff. Then let's convert it to an NS URL, and we'll do it the clean way this time, so you can start to learn the safer way of programming. Rather than like force unwrapping everything, you should use if let. So we'll do if let URL equals NS URL from a string, URL string, then, so that means make an NS URL from our URL string, and if it works, put it into URL. If it does not work, don't execute this code. Before we were just doing like exclamation mark, which is it's fine to learn with, but as you progress, you'll use it less and less and be a bit safer in your code. Inside that, we want to try and download the data from the feed, all this text. Now, wonderfully, there's a class available called NSData, Next Step Data. It's an old school class again, but it loads any kind of data from any available URL. Anything NS URL can point to, NSData can download, which is fantastic. And we can then parse that data and get information out. So we're going to say if let data, again, optionally unwrapping it, keeping it real safe, equals NSData, and the options are base64 encoded, bytes no copy, coda, contents of file, contents of URL. Fantastic. Contents of URL with options and error. If you want to, you can choose. I'll choose that one. The URL is just URL because that's the one that's been unwrapped from our string. Options will specify all zeros and error nil. But again, in your own code, you want to go back here and add some actual NS error stuff. We do that properly later. I think it's like 27, 28, 28 we finally start doing NS error correctly, but that's all right. We'll get up to that much later. But now it's fine. So if we have successfully downloaded an NS data from that URL, then we want to try and parse it using Swifty.json. And to parse it, it's so simple. You just say, let JSON, my constant, equals JSON, all in caps, then data. That's it. That will convert all that text into a Swifty.json parsed object we can then query. And querying it is so natural. Once you've seen the structure inside something like JSON format, or once you can start to see that there's a metadata field and a response info and a status, it is so simple. Because you can literally say inside here, if JSON, square bracket quote, metadata, has response info, and that has status, and its int value is 200, then we're okay to parse. Oops, like that. That is guaranteed to work, which is so wonderful. That's the smart thing about Swifty.json. What happens is it will navigate through the JSON. It finds metadata, finds response info inside that, then finds status inside that, then extracts its integer value and compares it against 200. So you can see it'll go metadata, response info, status, that value, compare against 200. If it's 404 or whatever, it means it wasn't found and it can know it's an error, but 200 means it's okay. And the amazing thing about Swifty.json, the thing that makes it so much easier than regular Swift JSON parsing, is the fact that if for some reason metadata does not exist, or if that exists but this one doesn't exist, or if it actually hasn't got an integer value, whatever, it will automatically return the default int value, i.e. 0, which is amazing because you know exactly this call will always work. Even if values are missing, it will still return something and it will fail our test because it's not 200. Which makes our life much easier. So recap, we give a URL string, it's variable because we're using it later to change the petition URL. We conditionally convert it to NS URL, unwrap it safely, pass that to NSData to load up the text, Again, unwrap it safely, convert to JSON, and then check whether it came back as OK, i.e. 200. This, by the way, as you've seen several times already, is just a comment. And it's in green by default in Xcode. It means ignore this text. It's really, really good to have comments in your code so you can remind yourself later on what code does. And you will need to do that, trust me. But it's ignored by the compiler, so it's never seen by your program. So Swift.json is doing most of the work here. So what we're going to do is we want to parse, i.e. to go through the JSON and do useful things with it. In that we're okay to parse. So we're going to write a new method beneath viewDidLoad called parseJSON. Parse, P-A-R-S-E, JSON. And it takes an object, the thing to parse, and I'll call it JSON, and it's of type JSON, upper caps, like that. This will do the actual JSON parsing. It'll go through and say, okay, get the first petition, get a second one, third one, fourth one, fifth one, and so forth. And again, Swift.json makes this so clean and simple. All you do is you say for result, that's the name of giving the thing, in JSON results. That, by the way, is the name of the key in here. So you see metadata is there, then beneath that you'll see results. So it'll loop through that. We want to say, actually, that's an array. So we had int value, we'll now use dot array value. Give it to me as an array. And again, if there's nothing in there, if it doesn't exist, it will automatically return an empty array. So this code will always work. It's just fantastic. So we're now going to pull out from the JSON the title field, the body field, and the signature count field, which is a reminder. Let's have a look. So title is just called title, body is called body, and, well, signature count is called signature count. So quite straightforward then. So inside here, loop through every result in our petition and assign it to constant. So we'll do let title equals result, bracket, title, and then dot string value. So we know it's a string now. That's 1, that's 2, that's 3. We want body in there, and we want signature count in here. Signatures, by the way, is an integer if you look. There we go. So 370, it's a number. So we can pull that out as an integer, or we could pull out as strings. It does the right thing automatically, which is quite nice. So we'll do let title there, let body there, and let sigs there. So it'll ensure we get the right value back each time, and we're then going to put that into a dictionary that holds a string and a string. So title will be title, body, body, and sig, sigs. So we're going to say let dict equals bracket title colon title, then body colon body, then sigs colon sigs, like that. That creates a dictionary from our values, and we'll append that to our array of dictionaries. We'll do objects dot append obj, like that. So it'll pull out title, body, sigs, and append it to the array. It is complaining. Oh, because object dict. Sorry. There we go. That adds the dictionary to our array. And once parseJSON is finished, once it's finished loading the JSON, we want to reload the table view, like that. So table view now reloads correctly. Now we need to call this thing somewhere, because obviously it's just a function right now floating in the middle of nowhere. We need to call it, and we'll put it in here where it says we're okay to parse. So you can delete that line and replace it with parseJSON and pass in our JSON object. That now will read from the results array from the JSON object it was received. It will loop through and hopefully create arrays of stuff and pass it off into our dictionary. What we can do now, just to make sure it's all working correctly, we can print out the value. So we'll do it down here. We'll say, actually, can I press? Let's try and press play and see what that does. See what it does. Yeah, it's whinging. Whinging. Aha, I know why. Let's do a little cheat in here. Let's put back in description again. It was there before. We took it out. That is a dirty hack, but it will at least work for now. And let's see what that does. Okay, so you can now see in the title field, all the titles from our JSON has pulled them out correctly, which is fantastic. That was not hard at all. All works very nicely. So you can see it's working correctly. Cool. It's okay for now. So what we're going to try and do is use the title subtitle thing we have going on with the cell as configured in the storyboard. So you can see we've got cell text label text equals object description. We know this object is a dictionary of string and string, so we can say object title. So put the title in the text label, and there's another property of the cell because it's a subtitle style, which is called detail text label. And there we're going to put in body, like that. So it'll put the title of the petition into the title area and the body into the detail text label. That's the bit beneath. This obviously will not fit. Some of them are very long, but it will show the first, 8 or so words in there and truncate the rest automatically. So we now see the title and then body beneath it, which is fantastic. This is working really well already, I think. We could say actually not body, but 6, showing how many signatures each of these things have. Let's see, so not very many. Well, that's doing very well. Mostly not that many. That one's doing quite well. Well, that's doing very well. So there's quite a few things going on here. But you can see it's working correctly. We're now grabbing the data and showing it in the table view using the subtitle style and our array of dictionaries. This thing is actually coming together quite nicely. So I'll put that back to body again, which is what it should be. So we're setting the dictionary correctly from the feed. We've got it all coming through a table. This is kind of actually working well so far. But it's now time to render a petition to show the body view somewhere. And we'll do that inside the detail view controller in the same way we've done already. When we made our little web browser project in project 4, we learned how to do this using WebKit. So we can go to the detail view controller here and then modify this so it's not about detail labels anymore. Instead, it's about a web view, which is much more interesting. So let's fix this up slightly. We don't need half this stuff, so let's actually go to the storyboard again, just frag it from here. So delete that label entirely. Then go back to detail view controller.swift, zap that outlet, you don't need that. Detail item, the thing to show, need none of that stuff. What this should be, if you remember, is dictionary, string, like that. Is exclamation mark in the end because it'll start life as being nil and become non-nil over time. So it'll pass through one dictionary, one item from our array, which is the petition that was tapped. We need to import WebKit, if you remember, so we can start using the WK web view as seen in project 4. And we're gonna load the view here. We don't need this configure view thing anymore. It's all useless. Get rid of all that stuff. Get rid of it from there too. In its place, we're going to create the load view method again, just like in project 4. So let's make a web view property. We'll call this var web view, and it is a WK web view exclamation mark. Then did load, we'll say web view equals WK web view, and then self.view equals web view. That's what it takes to set up the petition. But the interesting thing comes in actually rendering the petition inside here somewhere. In fact, wait a minute, I've done this slightly wrong. Please accept my apologies. That code should go in load view like that. Sorry. You have completed project 4, I'm sure. You spot that error straight away. You experience SwiftCoder. So we create the web view and make it our own view inside load view. And view did load, we'll do something else, which is where we render the petition. And we're going to use HTML because it comes in. Let's look at the format again. It comes in just full of stuff like this. And we don't have to try and parse this ourselves. We want to just make it, just throw it all onto a screen somewhere and let users scroll around. And web views are very, very good at that. You can even add some of your own styling to it if you choose to. So we're going to load some HTML here in ViewDidLoad. This book is not called Hacking with HTML. That'd be quite tedious. So I'm not going to teach you too much about HTML. So I'm sorry. If you want to learn HTML, go somewhere else. We are instead going to use the minimum amount of HTML required to make this thing look halfway decent on the page. And that's done using a special meta tag, if you know your HTML, saying it's designed for mobile devices. Plus we'll bump up the font size just slightly. So what we are going to do first is pull out the body of our dictionary. So we'll start off with InViewDidLoad if let body equals detail item body, like that. So if we've managed to find body text in our thing, which should be always there, then we're going to create some HTML, var HTML, and it's going to be a string, which is Pulp Fiction brackets HTML, like that. Then we're going to do tons and tons of lines of HTML, well, maybe 10 or so perhaps. Each time using plus equals, add and assign, just so it's all neatly in different lines. There are more efficient ways of doing it, but actually this is the simplest way at this time. So we'll say HTML plus equals a head tag to do some metadata. Then we'll do HTML plus equals, this is the metadata stuff. We're going to say meta tag, meta name equals, you need /quote viewport /quote, and it's /quote, 'cause if you had a normal quote it means end the string. /quote means I want a quote here, a real quote, don't end the string. Meta name equals viewport, content equals /quote, width equals device width, initial scale equals 1 /quote, end Pulp Fiction bracket quote. I am not going to explain this stuff to you because it's not HTML course, but that does just make it optimized for mobile devices, which is good. Then we'll add some CSS to make the font just slightly bigger. So plus equals style. Body can have font size of 150%, which is great. And then end the style. Style like that. Then we'll end the head tag. Oh, HTML is so tedious to type, it really is. Head, end head, even, end head. Then we'll start a body. Then we'll add our body as extracted from the dictionary. So we can do HTML plus equals body. Then end the body tag. Then end the HTML tag. And to think these people call themselves programmers. HTML like that, brilliant. That is just enough HTML to make our thing work correctly. It's very raw, but it works, quite frankly. We can now pass that to our web view using webview.loadHTML string. And tell it, use the variable called HTML. Base URL, what is this related to? And you're on the internet, we can just say nil, it's nowhere, just some HTML we made ourselves. That is the simplest HTML I can give you without getting into more detail. We just create some stuff using our body, make it mobile optimized, make the font size a bit bigger, and throw it into the web view. We should now hopefully be able to press play. So we've got our tab bar control across the bottom, as you've got one tab in, a lot of things we can flick through, choose on one of these, it'll pan in, and then, oh lovely, some racist issues, intentional promise. There's something funny in here, or something less worrisome than, no. Okay, it's all serious stuff. It obviously is mostly for serious use, let's face it. So that's it for the detail view controller, because it's just showing the stuff in HTML. I mean, you can obviously, if you know HTML, you can add more impressive style sheets and stuff, or your own code, but that's enough to get going with our petitions from the Whitehouse as it is. So we're going to make a couple more changes, literally 2 more changes. First, I want to add 2 tabs here, a popular tab and a recent tab. This one right now actually is the recent tab, so let's rename that to be recent. So let's go over here, select our tab, and then go to here and say recent. That's our recent tab already. We want a popular tab, which ones have lots of signatures. Then we're going to try and make our NSData code a little more resilient by adding error messages, just a little bit. Just want to try and spot the error and say there was a problem. Not too hard to do. So how do we add more than one view controller to a tab bar controller without duplicating our scenes, our storyboards, which is not very pleasant at all? The answer is doing code. And there's a whole file here. It's been there all along since Project 1 called appdelegate.swift. We haven't opened it once yet, but it does contain some important code. And this thing contains the code required to start up your application and monitor its use. Did it go to the background or the foreground? Was it asked to load a URL? Did someone try and share files with it? Did it receive a push message, for example? It's all contained inside the app delegate. And with this, we can find, when the application is finished launching, we can find the tab bar and add things to it to customize it before it's visible to users. So you'll see this very first method here. It's called application did finish launching with options, which is the point, as you can see here. We can add our customizations just after it's finished launching, before anything's visible. So in there, before the return true, we want to get hold of our tab bar controller. This is actually quite easy to do because we already have this window variable thanks to the template, and that tells us the window of the thing. We can ask it, well, what is your root view controller? What's at the core of your window? So we can say var tab bar controller equals window dot root view controller. Now it'll fill in a question mark for us because it's an optional. That's fine. So that is any kind of UI view controller. It's not necessarily a tab bar controller, but we know from our storyboard that it is a tab bar controller. It just is. That's the way it's designed. So in app.delegate.swift again, we can say literally as UI tab bar controller. Treat this as if it were a tab bar controller. And when that's done, we can go ahead and add more tabs to the tab bar controller, because you'll see tab bar controller has this property called view controllers, an array of any object, which really means the array of view controllers. Even this help thing tells us that. We can add things to that, modify it, and customize it to fit our application's needs. So we are going to try and load another one of these navigation controllers. And to do that requires a new class called UI storyboard. That loads storyboard files like this one and lets you work with it. So beneath var tab bar controller, write this. Let storyboard equals UI storyboard. It'll ask for a name. Ours is called main, as you can see, main.storyboard. And bundle nil. That means just in the current bundle. That'll load the storyboard. We now want to pull out from there the navigation controller, which will in turn control the table view controller. And this is done using a storyboard identifier, which we gave right at the beginning. We selected this thing and went to the identity inspector here and gave it an ID of nav controller. So we can now finally use that in our code. We can say var vc equals storyboard dot instantiate view controller with identifier. Brilliant long method name, but it's totally self-describing. Give it the identifier to use. We chose nav controller, and then that will return any kind of view controller. Of course, it doesn't know it's a navigation controller, but we can now say as UI navigation controller, so we know it works. Finally, we can give that a custom tab bar item. So we'll use one of the system ones. We'll say vc.tabBarItem equals UI tab bar item, open parentheses, system item, or title, if you want to do custom ones down here, but let's face it, the system ones are easier. System item will use dot top rated and give it a tag of 1. Now you remember in project 2 with the flags, all 3 flags called the same method, and we distinguish between the flags by using a different tag, 0, 1, or 2, with 0 being the default for all things that are created with tags. Giving this thing a tag of 1 means we can now distinguish between the top rated view and the popular view. One has a tag of 0 and one has a tag of 1. We'll come back to that in a second. So that finishes the app delegate code mostly, because we've created the storyboard, we've pulled in the view controller, we've given it a tab bar item. The last thing to do is set that inside our view controllers array. And we do that by saying tab bar controller dot view controllers, which is optional, dot append vc, like that. So it'll append it to its current array of view controllers. So it's all new, UI storyboard, instantiate view controller identifier, UI tab bar item, view controllers array. It's all new, but none of it's very hard at this point. You're a real Swift pro by now. But let's look at what this tag does. We've got tag 1 for the top rated stuff, the popular feed, and tag 0 for the other one. And what we can do is we can check that inside master view controller. So we're saying one navigation controller has a tag of 0 and the other one has a tag of 1. So in master view controller.swift, you will see this line of code var URL string equals that long string. We're going to change it depending on the tag of the navigation controller it's inside. So instead of that, we're going to write var URL string : string. So saying what is variable URL string, it's going to hold a string, but nothing just yet. And then we'll say if navigation controller dot tab bar item dot tag is 0, then load in, then we'll set URL string to be that. Else, everything else, we're going to change this feed just slightly. So it's still API WhiteHouse.gov /v1 /petitions.json question mark. We're going to do signature count floor equals 10,000, and then 100 items going back. So this is a way of saying to the API, obviously you can define your own API. This says I want to only see things that have had at least 10,000 signatures when I'm in that tab. So now we have two ways of loading the data. If you press Command R now, you should be able to see both of them working correctly. So the first tab, we have the recent stuff, and on the second tab, we have popular stuff. So it does look extremely similar, but you'll see there are fewer in this one, which tells me maybe I got it wrong. See, look at that. They need a little ampersand in there. I'm sure someone out there was screaming at the screen saying, "You missed an ampersand, you fool." Let's try that again with the ampersand. Again, number 1, recent, and number 2, top rated. There we go. These are the most popular petitions apparently. Again, they're all very, very serious, unsurprisingly. But they're different. So you've got a bit of interest in your application now. Two different ways of viewing the same data, all by just changing that variable. So the project is now almost done, but we're going to make one last change. See, our current loading code is not particularly resilient. We've got all these if statements going on here, checking that things are working correctly before we parse JSON. There's if, then if, then if, and if all three are true, then parse JSON. But there are no else statements. There's no way of showing error messages if things have gone wrong. So we're going to add a new method called showError that shows an error saying something went wrong, sorry, and we'll use that in place of all the else statements. So beneath viewDidLoad, make a new method called funcShowError. Then we'll use alert controller again. You should be used to this by now. Let AC equals UI alert controller. Title, I'll call it loading error, and a message should be something like, there was a problem loading the feed. Please check your connection and try again. Fantastic. This should be alert, state change, something's gone wrong. We'll add an action to it, just saying okay, so it can be dismissed. So UI alert action with the title okay, style default, handler nil, i.e. just go away, and then present view controller AC animated true, completion nil. Fantastic. So that will show an error message. What we have to do now is adjust the code, so every time there is an error, one of these things fails, it calls show error. So if we didn't get 200 back, else show error. Great. If the data could not be loaded correctly, else show error. And if the URL is just wrong somehow, shouldn't happen, but there you go, show error. So 3 else show errors. And that finishes the program. So it still works. You've got these two tabs going on. You've got the JSON being parsed. You've got all those error messages in there now. This is actually a really nice finished app using live data from the web and even a bit of WebKit in there again. So you've had another go at learning things like navigation controllers and table views and stuff, but at the same time you've now discovered UITabBarController and NSData, which are two really important iOS controls we're using time and time again. And again, JSON is amazing by itself. We use JSON a lot. It's a very popular data format. So if you have developers out there working with you on a website and you want their data, they'll probably use JSON. For more information, please go to the website hackingwithswift.com, where you can buy this video in high resolution, or the book for the tutorial, which contains tons more information to learn from and explanation, or you can buy the whole series. Regardless, your support does help me make more videos like this one. Alternatively, grab me on Twitter. I am at 2straws. I'll do my best to help you if I have time. Please get in touch and I will do questions, answers, support, chat. Hit me up. I'm bored half the time. Let's talk about ice cream and movies. How about that? Fantastic. Or, of course, Swift. I don't mind. Get in touch. Have fun.